Good day. Today we're looking at graphing square root, cube root, and reciprocal functions. For a square root function, you have y is equal to the square root of x. If you want to see what it looks like, you can type this in Desmos. There you have the graph. The key thing to note on this, I have a coordinate at my origin, and now I'm following the path such as what a quadratic would have. There's my graph. My endpoint is 0, 0. My domain is going to be 0 to infinity. Square bracket on the 0 because I do touch x equals 0. Or an x value of 0. Parenthesis on the infinity. My range, 0 to infinity. Because I stop at the x-axis and I'm going upward. A cubic root functions all the way down. Looks like this. It is y is equal to the cubic root of x. It does touch the origin. And it looks like that. Turning point is at 0, 0. So turning point is more or less the middle of the graph. My domain is all real numbers, and my range is all real numbers. Okay, there's your first part. Now you should be familiar with the transformations of these functions. They are the same as a quadratic, but here they are. There's your formula. H is your horizontal shift, plus is left, minus is right. K is vertical, plus is up, minus is down. Your endpoint or turning point is at H at K. If A is negative, you reflect it across the x-axis. If it's greater than 1, it is a vertical stretch. And if it is in between 0 and 1, it is a compression. Now, you are able to use Desmos on any of these problems. However, I'm not going to use Desmos on these because it is good to know them by hand. So here we go. I'm going to do number 3 and 4. Then I want you to pause it, try 1 and 2. Number 3, I have a negative, so I'm going to reflect over x. That's the negative part. I have a plus 3 under my radical, so that is left 3 units, and that is everything in this problem. Number 4, the 1/2 is an a value. This is in between 0 and 1, therefore this is a compression. Vertical, but compression. I have a minus 2 under the radical. This is right 2. And I have a minus 6 on the outside, which is down 6 units. Okay. Pause it, try 1 and 2. Now here's your answers. The square root of a parent function is reflected across the x-axis, shifted 7 units left, 1 unit down, write the equation. All right, square root parent function. Y equals square root. All right, it is reflected across the x-axis. I need a negative out front. Then it is shifted 7 units left, plus 7 on the inside, 1 unit down, minus 1 on the outside. That is all my information I'm given. I'm going to put in the x. There's my formula. Y is equal to negative square root of x plus 7 minus 1. Try number 6. Well, actually, let's talk about number 6. A cube root function has a turning point located at negative 2, 3. Now, the reason why I want to try this gives me an h and k value. Now, look up above at the transformations and see what your h and k values are, how they're laid out inside of the problems. Now, here's the reason why I tell you that. If you remember the top under the radical, it is x minus h, which means this is x minus negative 2 cubic root. The k is on the outside, and it's plus k value 3. From here, I'm just going to distribute that negative. Y equals cubic root of x plus 2 plus 3 on the outside. All right. Graphing radical functions. Given the function, graph the picture. Now, I'm only going to do one of these, and I'm going to let you try the other ones if you want, then I'll show you the answers. But you have Desmos. The only thing I really care about is that you can fill out this side. So, here we go. I'll do number 9 because it has the vertical stretch. I'm going to type this in Desmos. 3 square root x plus 1. All right, if I look at my graph here, it is a 10 by 10 in the positive direction. So I'm going to change my x-axis to negative 10.5, that's just a little bit to the left, to positive 10.5, and same for the y. I recommend that just because it gives you a better picture. So here's my graph. I'm going to click it. I want those intercepts. And from here, I'm going to give a pretty good graph, best that I can on this. It looks something like that by hand. Anyway, close enough. My domain for this problem. This is a square root problem, so my domain is from the lowest x value, negative 1, to infinity. My range for this problem is the lowest y value, 0, is going up to infinity. My endpoint slash turning point, this is my hk value, negative 1, 0. In behavior, as x goes to the right, y is going to be going up. As x goes to the lower bound of the domain, negative 1, y is going to 0. Increasing intervals. So looking at the domain, where is it going upwards? Keep in mind you read left to right, so I'm starting at my lowest value of x, and I'm going to the right. So everywhere along that highlighted line is increasing, therefore it is my domain, negative 1 to infinity. You don't have to put a square bracket on the -1. A parenthesis is sufficient because I'm talking about the interval of increasing. Decreasing never happens in this problem, does not exist. Okay. There's the graph in Desmos. There's it by hand. Try number 7 and 8. If you want, here's the answers. And there's the diagrams. Reciprocal functions. Now for me, I think these ones are fun just because it is the inverse of a linear function. Here we go. A reciprocal function is 1 over x. Now a parabola is x squared. This is a hyperbola, and it looks like that. Again, it's 10 to 10 on my axes, just to give me a nice picture. My domain of a hyperbola. I can zoom out and you can see the lines are going both left and right. Notice it never touches the y-axis. X equals 0 is never a coordinate. Here's my domain. You can say two things. Number one, you could say all reals but, semicolon for but, x does not equal 0. Or you could put negative infinity to 0, union, that was a very bad U, union 0 to infinity. I don't care which one you do, pick one, do the same thing for range. Now I do ask you to notice for the range, you can zoom out and it goes both up and it goes down. However, it does not touch the x-axis, so y equals 0 is not an answer. So I'm going to write this one in set notation. The set of y values such that y is not 0. That says it can be anything else, it cannot be 0. I just wrote that in set value to give you another representation. I don't care how you write the domain and range as long as it is correct. Okay, vertical asymptote. The up and down is one I'm not touching, and that occurs at x equals 0. Horizontal is at y equals 0. Okay? Now let's draw my lines. I'm going to put a dashed line on my asymptotes because I cannot touch these lines. Those are the values that it will not ever touch. I'm going to draw my graph now according to these lines. I'm going to get close to the x, but I'm not going to touch it. Then I'm going to come down close to the y and not going to touch it. Same thing for the top right, quadrant 1. There we go, good enough, especially since we have Desmos. Here's your standard form of the reciprocal function. Now notice this is similar to what we was doing before, and much of the transformations are similar. Now notice there is no end/turning point because the domain and range is all real numbers except for a singular value. All right. A vertical asymptote is that x is equal to my h value. So no matter what I'm transforming the h, that is going to be the new vertical asymptote. So for example, for my h value, so negative, my h value is going to be 7. Notice how it shifted the graph to the right 7 units. I have a new vertical asymptote at x equals 7. Okay? That's what that's saying. For my horizontal asymptote, it's my k value. So if I put a number like 5, there's the graph. Notice how it shifted up, and this 5 is what I'm getting infinitely close to. I do want to show you one thing in Desmos. Desmos cannot graph a concept of infinity very well. If I follow that line, it might not do it with this one, but it will do it at times. After I go so far out, it will give me 5. So right there is 4.9 repeating. If I keep scrolling out, it will eventually hit 5. I want you to know it is never actually 5 for what I typed. All right, writing the functions. I'm going to do one of these, and I'll let y'all try the other two and then show you the answers. Let's do number, I think 1 has the most information. Let's do number 1. The reciprocal parent function is reflected across the x-axis. So because it is a reciprocal function, y equals something with a line. I need an x on the bottom somewhere. It is reflected across the x-axis. I need a negative. It is translated 4 units to the right. Minus 4. And it is translated 3 units down, minus 3. Write an equation to represent the new function. Identify the asymptotes. It says nothing about a stretch or compression. Therefore, my a value is 1. There's my equation. You can type this in Desmos if you want to get a look at it, but I'm going to find my h and k values. My h is positive 4, because remember, I am flipping the sign. Instead of negative, it's positive. And my k value is negative 3. What this tells me is I have a vertical asymptote, and that's going to be at x equals 4. I have a horizontal asymptote, and that's at y equals negative 3. There's everything on that problem done. Try the next two, pause it. Now here's your answers. Last part. Graph each function, identify domain, range, and asymptotes. You have Desmos. This will be easy for you to do in Desmos. I encourage you not to start in Desmos. Try it by hand. I want to do number 9 with you. I'm going to let you do the rest because, again, you do have Desmos, but I want to show you how to do 9 by hand. Number 9. I'm going to start by identifying the transformations and my h and k value. So first, my negative here is a reflection over x. My minus 5 gives me a horizontal shift, right 5. This is also my h value, 5, plus 3 is a vertical shift. That is up 3. So my k value is 3. My domain range I will get after I do the vertical and horizontal asymptotes. My vertical asymptote is x equals 5. My horizontal asymptote is y equals 3. So, domain and range. Keep in mind this is everywhere except for at the asymptote. So my domain is all real numbers, but x is not equal to 5. For my range, it is all real numbers, but y is not equal to 3. Okay, let's graph my asymptotes. For horizontal, x is equal to 5. 1, 2, 3, 4, 5. I might have said horizontal, I meant vertical. Either way. For my horizontal asymptote, y is equal to 3. Those are my lines. Now, I'm drawing in red, don't write this. The parent function normally looks like that. Because of my reflection though, I am flipping it over that axis. So my actual graph is going to start on the top left and go up. And bottom right. There's my graph, my domain, and my range. Let's check this in Desmos, and then you can try the remaining problems. -1 divided by x minus 5 plus 3. The graphs look right to me. If you want to check your asymptotes, x equals 5, y equals 3. There they are. They do not touch. I'm good. This is correct. Go ahead and try the remaining problems there. Here's the answer key. I'm going to move slowly, but this is all that I have for you today. I hope you have a great rest of your day, and we'll see you next time.